my institute, saying that unless I changed my line of research, that they would have to take away my telescope time.
The biggest problem the flat Earth community was facing was to crack the code of the heaven. The heliocentric model's supporters had a very valid argument with claiming their model had an ironclad predictive system. And regardless of what many flat earthers believe, astronomers over the last 100 years have not been looking with their eyes closed. Most professional and amateur astronomers have always tried to find a new discovery to either change the current paradigm or confirm certain aspects. To give an example of the predictive capabilities of the mathematical prediction system that is the heliocentric system, astrophotographers can look up coordinates in the sky for objects like star clusters, nebulas, or galaxies, for lack of a better term, which are completely invisible to the naked eye and high-power telescopes. Then they open the aperture for a long time, and when done long enough and in the right color range filters, the objects become perfectly visible. Something every flat earther has to realize is that there wouldn't be a market for trackers or telescopes if their model was incorrect in that regard. Instead of trying to find holes in its algorithms used to predict, we as a community should embrace the fact and be thankful for all the hard work that has been done for us. What we are doing here is simply applying their algorithms and build those on top of a physical construct to make the concept not only a real possibility, but considering the fact that modern astronomy is already shifting towards the electric universe model, this flat electromagnetic model is far better explainable and provable than the current hypothesis, that being the Newtonian or Einsteinian universe. In short, the argument that there is no flat Earth model and that they can't predict is out the door. The burden of proof now lies on both camps to empirically verify which one is correct.
Run.
Standard theories dictate the faster an object recedes from Earth, the farther away it is, because the primordial Big Bang explosion is supposed to have imparted an initial push that's causing the universe to expand. Using those theoretical parameters, a faster recessional velocity means greater distance, which means an earlier time period in the universe. And since an object almost 11 billion light years away is from the so-called early days of the universe, it shouldn't exhibit such complexity of form because there wasn't enough time since the Big Bang for that complexity to evolve.
Astronomers are surprised to find a high redshift galaxy with spiral structure. It has a redshift of 2.18, and most galaxies with that high of a redshift have irregular shapes. This one has well-defined arms, and it even has a companion at the end of one of them. The Big Bang theory assumes that redshift is an indicator of distance, which would put this galaxy at about 11 billion light years away. If it's that far away, it's therefore large and bright. But modern astronomy dismissed the observations of many astronomers in the last half of the 20th century, astronomers like Halton Arp and the Burbages. They found that high redshift objects tend to cluster around nearby low redshift objects. They found many physical connections, and they even found some high redshift objects in front of low redshift objects. These observations were misrepresented, and the misrepresentations were disproved. So with that excuse, the observations were dismissed and the Big Bang theory was saved. This is kind of a new scientific method. Instead of observation theory and testing, the data is judged by its conformity with belief. If it doesn't conform, then there's something wrong with the data, and the data is dismissed. In this case, fervency of belief replaces testing. If redshift is not proportional to distance, then the universe is not expanding, and there's no Big Bang.
The same electric force responsible for a galaxy's redshift may also give rise to its spiraling structure and other features such as polar jets.
One of the most significant contributors, I would say, to plasma cosmology and the electric universe theory was Dr. Anthony Peratt, a plasma physicist. And he was a protege of Hans Alfvén, the famous Nobel laureate. And Peratt studied plasma formations in the laboratory for many years. And what he did was create what are called particle and cell animations on supercomputers. Galaxies are, rather than being condensations of gas and dust that are gravitationally bound together, were actually plasma formations. And he thought that these simulations showed that cosmic plasma is confined due to self-consistent magnetic fields. And these magnetic fields are induced by currents that are flowing through the plasma, creating filamentary structures. And a cross-section through these filamentary structures indicated the formation of several galaxy configurations, and among those configurations were elliptical and barred spiral shapes. So Peratt insisted that plasma, along with electricity, engenders the structures in the universe. And since galaxies are often strung like pearls through space, or like beads on a string, that galactic arrangement lends credence to that idea.
In the beginning was the Big Bang. We are told that 13 to 20 billion years ago, everything that makes up the universe as we know it was spontaneously created out of nothing through an unimaginably violent explosion. But did it really happen as we are told? A growing number of astronomers doubt it and are showing why. This is their story, the story of the universe.
Observational aspects of trying to understand the universe, I think it's reasonable to start about 100 years ago. And about 100 years ago, almost everybody in astronomy, without question, assumed that the whole of the universe was what you could see in the Milky Way. Nobody felt that the universe was any bigger than the stars that you see in the sky, associated with our own local Milky Way. And that was the situation certainly around 1905, times like that. They're well-known people who propounded these ideas. 10 years later, Einstein first proposed his general theory of relativity. Now, when Einstein proposed this, it's a theory of gravity, which means that it's a theory which should represent the whole of the universe, because it's gravitational forces that are controlling the universe. Well, Einstein made this theory around 1915, and he immediately wanted to try and use this theory to explain the universe as it then was, the so-called Milky Way system. But of course, the idea of this was that it was a static system. That is, it wasn't contracting or expanding, it was a static system. And Einstein found that his equations did not allow for a static universe unless he inserted a certain constant in the mathematics, which became known as the cosmological constant. But what happened in the early 1920s was that a very clever Russian called Friedman in 1922 found solutions to Einstein's equations which allow the universe to either expand or contract. Now that was done in the Soviet Union soon after the revolution, and nobody in the West knew about this, I think. But in 1927, a Belgian priest, the Abbé Lemaitre, as he later became, also discovered these solutions. And he went to England, and his work was publicized in Cambridge and elsewhere, and the famous English astronomer Sir Arthur Eddington and others got to know about this, and they immediately began to say, how can this apply to the current universe? Well, in the same period, in 1929, Hubble made what I still believe was the most important discovery in extragalactic astronomy in the last century, or the last century but one. He showed that if you look at the spiral nebulae, the faint spiral nebulae, the shifts in their spectra are proportional to their apparent brightnesses. And this led very soon to the idea that this fitted very well with the expanding universe, and that indeed this is the kind of universe we lived in, that what we were looking at are galaxies, Milky Ways, further and further away from us, and the further away from us, the larger the redshifts. And if that's interpreted in the way that most people would interpret it, this means that they are moving away faster and faster. So this was the original idea. By the 1930s, the front page of the New York Times said we live in an expanding universe.
When Hubble made his great discovery, it was for galaxies like our own Milky Way galaxy, and they all followed the same rule, that the fainter they are, the larger their redshift. In other words, the faster they are moving away from us. This is known as the Hubble law, and directly led to the expanding universe theories. But in the 1960s, there was a new discovery, the quasi-stellar objects, often referred to as quasars. They appear as star-like points on the sky, frequently blue in color, and they have very, very large redshifts, implying that they are at huge distances from the Earth, at the very boundaries of the observable universe. Some astronomers soon found that a vast number of these strange new objects populated the regions around spiral galaxies, and were not only observable with radio telescopes, but were optical and X-ray sources as well. There were two properties of the quasars that were difficult for astronomers to understand using the expanding universe theory. The first was that if one plotted their apparent brightness against their redshifts, as one does for galaxies, one gets an unexpected scatter on the diagram, instead of the smooth curve made by the same plot done for galaxies. This seems to indicate that the quasars do not follow the Hubble law as do most other objects, and that there is no direct indication that they are actually at their proposed redshift distances. In fact, it is argued that if Hubble had first been given the plots for quasars, he and other astronomers would never have concluded that the universe was expanding. The second property was that quasars are very small, compact objects, sometimes only a light year across. So if quasars are really at their extreme redshift distances, they must then be the brightest and most energetic objects known to astronomers. So energetic, in fact, that untestable, almost metaphysical mechanisms must be applied to explain the phenomena. On the other hand, when placed at their observed distances, that is, in the neighborhood of nearby galaxies, their brightness and energies become normal, and no special mechanisms need to be evoked. This problem has led many astronomers to abandon the idea that all redshifts are due to their speed of recession away from the Earth. And if this is true, then there is no need for an expanding universe, and the Big Bang never happened. The questions arise. Is there a connection between certain types of galaxies and the quasar? Are quasars ejected from galaxies, and in fact proto-galaxies themselves? Is there some other astrophysical process which can explain the redshift discrepancies? One of the world's most controversial experts on the structure and morphology of quasars, Halton C. Arp, has for 35 years proposed just such an idea. For the heresy of opposing orthodox interpretations of the redshift problem, Arp has had to pay a heavy price, the same price paid by many a scientist with new and innovative ideas. Dr. Arp was forced to resign from his permanent position at the Carnegie Institute of Washington Observatories after the Caltech head of the Telescope Allocation Committee threatened him by saying, unless he changed his line of research, they would take away his telescope time. Due to this fact and his ongoing struggle against the established paradigms, Arp is often referred to as the modern Galileo.
I remember when I sent the paper into, the first paper into Astrophysical Journal on the nature of companion galaxies, and I had a lot of them on the ends of spiral arms, so I was sure that they were connected, and I showed that they were systematically redshifted. I sent that in with naive, great expectations that people would be terribly interested and impressed on this. And the editor of the Astrophysical Journal at that time was Subramanian Chandrasekhar, who had a fantastic reputation as a master theoretician and also quite an incomprehensible theoretician, and a tremendously powerful figure in the field, and editor of the Astrophysical Journal, which is probably the most powerful position in the field. And he chose not to, in his wisdom and judicial fairness, chose not to send it to a referee, but he just wrote across the paper, "This exceeds my imagination," and he sent it back to the director of my institute, Horace Babcock, with the obvious implication, you've got to do something about this staff member of yours who's doing these very bad things. And so Horace called me down in the office one day after this, and I walked in his office, into the director's office, and I saw this paper lying in front of him with Chandrasekhar's scroll across it. And Horace looked at me and said, well, he said, this is just too much, and you're going to have to start looking for another job. And so all I could say to him was, well, if you send me that in writing, please send me in writing. And I was waiting in great trepidation for weeks and months to get something in writing, and I finally never did, so I realized that he decided to give me another chance, so to speak. So that was fairly early in the game, and then some years went by, and there was the competition for time, particularly on the 200-inch telescope, was getting more and more heated, and people were saying, well, we can't continue to give time to this obviously incorrect and embarrassing research that ARP does. So finally they sent a letter to me from the allocation committee, including a number of the younger members of my institute, saying that unless I changed my line of research, that they would have to take away my telescope time. At that point I considered the situation very carefully, and I figured that the evidence, although a lot more evidence could be gathered and has since been gathered since then, the important thing was not the evidence, because if it was true, it would come out someday. The important thing was the principle of scientific investigation, whether scientists could follow new lines of investigation and follow up on evidence which apparently contradicted the current theorems and the current paradigms. And I also felt that regardless of what happened to me personally, that this was the important issue, and that I had no choice but to resign on the point of this issue, so that if it developed, which I thought it would, that my line of investigation was correct, that people then in the future would say, okay, this was the wrong thing to do, and in the future we're going to have to see that this kind of thing doesn't happen again.
The observers come in now with the belief that we live in a Big Bang universe, and therefore all of their ways of understanding things are tailored to that. And they don't come in with the possibility that our alternative, or any other for that matter, is right, and really do it in an open-minded way. And of course what goes along with that is that observers who would like to test this way find it very hard to get observing time and so on. I mean, this relates to the whole issue of whether the complete lack of balance in the way the observational programs and the funding are conducted. There's no question about that. I don't think that anybody would argue about it.
I've always said that the cause of the troubles is the American graduate school. You get one person who then lectures to his students in graduate class, and because you have a system, you see, when we had graduated first degree, we were independent. We could thumb our noses at the professor. And in fact, the best way to get ahead was to do something that the older people didn't agree with. Oh, really? Right. That was the way to do it. And but in the graduate school, you all have to learn what you're taught, what the professors are teaching you. And then those people go out and get jobs, and they have another graduate, their own graduate school. And it just, tier after tier, you get a few places like Caltech or like Harvard, and they set the fashion for every place.
I think there's a problem with graduate education. I think graduate education is not teaching students to think, to be independent researchers. I think it's teaching them to be part of a scientific society. And too much, especially students that are at the so-called elite institutions, I think they're taught too much the paradigm of their advisor.
All of us, whether or not we served in uniform, are veterans of a war in which freedom and free government are at stake. Such fullness of knowledge is the direct function of education. Most of us work hard to provide our homes with every possible comfort for our children. We safeguard their health. We strive to set before them good examples of moral living, of manners and deportment. Possibly, we even pamper them. Yet complacently, even carelessly, we commit our children to schools of which we know but little. We cannot meet the complexities of modern life with outmoded school systems. We must keep our educational standards abreast of the swift-moving times in which we live, if we hope to preserve our national heritage and our American way of life, the American way.
When I was director of the National Observatory 20 years ago, there was a very well-known astronomer now. In fact, she's just won the Cosmology Prize. That's Vera Rubin. She was carrying out a program at Kitt Peak at the National Observatory of observing faint spiral galaxies with a view to looking to their redshift distribution, their velocity distribution. And this was a program that everybody thought was a good program. And so she'd been given observing time, and at the end of about a year, she had completed about a third of her program. And so she actually wrote a little paper pointing out that she was getting results very different from the ones that were expected. And we had our usual meeting. And when we got to her program, which was an ongoing program, so people just looked it over, the leading extragalactic astronomer on my committee of that day immediately said, well, look, she's getting this result. It doesn't fit. It has to be wrong. I recommend that we stop the program. That was his position. And what was interesting to me was I sat there and listened to this discussion. And the majority of the people, because of his level of knowledge and authority, went along with him. So the recommendation of the committee was that we stop the program. Well, I had the last word, so I ignored it. But most people don't. And the peer review system and NASA itself, which is very conformist, will always do just that. That's one of the reasons why the road ahead is hammered out. As Hoyle said, anytime you point a new telescope at the sky now, you're only going to find what you already know is up there.
I have a lot of trouble with the academic world, the same as I do with the Bible Belt. It's the same kind of trouble. It's the same kind of trouble. It's because they get a picture of this world which they are sure is right.
Yes, yes.
And they hang on to it for all they're worth. But you know, I often point out that I am probably more unorthodox than anyone who has ever burned at the stake. It's illegal now.
Illegal burning.
It's illegal now to burn somebody to the stake in your backyard.
Peculiar galaxy NGC 7603, discovered 30 years ago by Halton Arp, is one of the more striking examples of galaxy-quasar connections. It has recently been re-examined after the discovery of two new quasar-type objects embedded in the connecting filament. The renowned optical astronomer Margaret Burbidge has for decades been a central figure in the struggle to bring controversial observations such as NGC 7603 to the attention of conventional astronomers, and for her fairness and untiring efforts in the field, she has become one of the most widely respected women in astronomy.
There's a very interesting galaxy known as NGC 7603. It's a Seyfert galaxy. That means it has one of these active nuclei with strong emission lines and a lot of activity, obviously, going on in its center. And it was studied years ago by Chip Arp in his Atlas of Peculiar Galaxies. It has a spiral arm that seems to come right outside of the galaxy, trailing right out, and it ends up on a fainter galaxy, but it ends right up as though it's connected the nuclei of the two galaxies.
In the Atlas of Peculiar Galaxies, which was published in 1966, that was the point of the atlas, and one of the objects, just to illustrate what a peculiar galaxy is this what is now famous NGC 7603, and this is the central Seyfert, which means just a very, very active galaxy with a lot of energy in the nucleus and a lot of explosive energy and so forth. And here is the high redshift companion here, and you see it's joined by a filament, a material. It turns out from the observations that this filament of material is material of the galaxy, gas and dust and stars and so forth, that's been drawn out in the ejection. But the astonishing thing and the controversial matter is that this galaxy is a much higher redshift than this.
Now, NGC 7603 has one redshift of about 8,000 kilometers a second, and the other galaxy has a much larger redshift. So how can they be connected? Well, these data were published years ago, and everybody said, well, this is just a chance location of a background galaxy near an interesting foreground galaxy, and that spiral arm has nothing to do with it. It's just the whole thing is just a chance.
If you see two objects close together with very different redshifts, you only have one of two explanations. One is, as I say, that a large part of the redshift has nothing to do with distance, and the other is that it's an accident. So the real issue that you come down to is how frequently do you expect to see accidents?
If you look carefully at the pictures that were taken of this field, you will notice two faint stellar objects that are in that spiral arm. One is close to NGC 7603, and the other one is close to the faint companion galaxy.
In the year 2001, when the two young Spanish astronomers worked on this with the Las Palmas telescope, they saw that there were these two condensations, stellar condensations. They looked like quasars, but everybody would have said that they had to have the same redshift as the central galaxy because they were obviously in this filament that had been ejected. What they found was that each of these objects had a much higher redshift, and that the filament itself had the same redshift and spectral composition as the galaxy from which it was ejected.
And they got some spectra using what's called the Nordic Optical Telescope in the Canary Islands on La Palma. It's not a very large telescope, but they got some excellent data, and they got spectra of these two faint objects, one by 7603 and one by the companion galaxy, and believe it or not, they showed that both of them were quasars. Not very high redshift quasars, but definite quasars.
A chance to have many quasars around a galaxy as a background objects. Of course, you have some chance, but these are very, very low, and this is what should be answered. This is what should be answered. NGC 7603 is a very special case of this correlation. You find not only 3 objects with different redshifts in the neighborhood of a major, safer galaxy. You also find the filament connecting all of them. So this is more important because the probability to have all these objects, not only in the neighborhood, but exactly in the filament, is extremely low.
The galaxy, which is an active galaxy, 2 low redshift quasars, and another galaxy with twice the redshifts. In other words, you had 4 objects all connected together, apparently, by a luminosity, by a luminous bridge, each with a different redshift. Now that, I would say, is pretty conclusive evidence for the existence of non-cosmological redshifts.
We were lucky because we have found that the object has more controversy than expected. If in the past Chip Art thought, and Barbies and other people that have dedicated some effort to research this object, if they thought that there were 2 objects connected by a filament with different redshift, now we have discovered that there are 4 objects all connected by the same filament, and all of them with very different redshifts. So the Doppler redshift is discovered.
I think they have to look at it, and I think it's one of the most striking results that we have available. How they can make sense of it other than saying that these objects, that these redshifts of connected objects that are the same, more or less the same distance from us, that these redshifts have non-cosmological components to them.
The topic of the anomalous redshift is very important for most of the areas related with cosmology and extragalactic astronomy nowadays. If we assume, as it is done nowadays, that all the redshifts are pointing the distance of the galaxy or the quasar or whatever, of course the results will be very different than assuming the other thing, that the redshifts are due to other reasons. The distance of the quasars and the galaxies will be different, the energies involved in the process will be very different, so a lot of astrophysical processes will have to change.
Conclusive evidence that the expanding universe was not correct, and that the redshift distance law was not correct, and that we had to have some way of creating new galaxies with high redshifts.
It is normally argued that the Big Bang, for instance, the Big Bang cosmology, is against the anomalous redshift question. And of course, the Big Bang theory is the most important theory that we have nowadays to explain all that we know about cosmology, which is not too much, in my opinion.
There's a large body of work going on, observational work, theoretical work, which is based on the assumption that quasars are at their cosmological distances. If it turns out seriously that we're right, then all that work is in vain. We don't know anything like as much as we think we do by saying that the quasars are far away. And that's another huge problem for people to face up to.
One of the frightening things, I think, for conventional astronomers is to accept the fact, or to realize, that these intrinsic redshifts for the quasars and peculiar galaxies and so on, active galaxies, means that a lot of the things which we thought were out at great distance in the universe are very much closer in.
Armenian astronomer Victor Ambatsumyan, who only died a few years ago, who also argued that galaxies which appear to be coming apart and objects that are coming out of them are coming out of them. Very simple idea, but Ambatsumyan, who was a very well-known theorist, always said you must look at the observations, and maybe if things are coming apart, appear to be coming apart, maybe they are coming apart. Conventional astronomers don't allow things to come apart. They always say there's enough dark matter in the system to hold it together.
I've come to the conclusion that what it is that will unseat an established prejudice, a strongly established prejudice, is one observation. One single observation, usually a very simple one.
The conclusion was very, very strong, just from looking at this picture, that these objects had been ejected from the central galaxy.
One of the best and earliest of the really controversial things was a Seafoot galaxy known as NGC 4319, which Chip Arp discovered that it has a protrusion coming out in the south direction from it, one of its spiral arms, and ending up on another galaxy known as Markarian, and people have tried to explain it away in all kinds of ways and tried to take false pictures to show that it's not there. But I've seen the good pictures, which were the first really good pictures were taken by Jack Sulentic.
NGC 4319 was part of some work that I did in the early 80s when I was a young astronomer, a young faculty member, and people were coming up to me and saying, oh, I've written a paper to show that what Chip Arp has done is wrong. There were at least 3 famous papers right around 79, 80, 81. And it took about 5 minutes to look at these papers to see that they were flawed. And one of them was a paper that claimed to show no connection between NGC 4319 and the quasar Markarian 205. So at that time I had the opportunity to work at JPL using the new image processing facilities that had been developed for the Voyager program, in fact. And it took 1 hour's effort to show that there was some kind of a luminous feature between those 2 objects. I don't know what it is, but there's no question that there is a luminous feature, and it cannot be dismissed in the ways that it was dismissed in the early 80s.
Suddenly there appeared press releases from Space Telescope Science Institute, which was the research arm of NASA's Hubble Space Telescope, and this press release said that they were not connected, and it gave a Hubble Space Telescope picture. It was not very deep, and you could just see 2 objects and no connection between them. And in this press release, then they said that that this proved that there was no contradiction with the current expanding universe paradigm.
No connection between the 2 objects. So I looked at their picture, then I downloaded it, and it took me 5 minutes to show that it's still there. Now, I don't know what it is, but I think you face up to the existence of the feature, and then you consider conventional and unconventional explanations. But I was really surprised that they felt it necessary to issue a press release saying, it's not there, it's not real. When it's the same thing we saw 20 years ago.
But it's hard to get people to look at this because they don't understand it. You see, it's again the non-cosmological redshifts.
We realized that the people who had been processing the pictures and released it must have known that the bridge was there, and yet they chose to try to convince the public that that in fact it wasn't there, and that everything was right with the current expanding universe paradigm.
It's a strange attitude. I don't understand it as a scientist, really. I think that news release could have generated much more interest in astronomy than many of the more conventional news releases, because people would be talking amongst themselves, gee, what could that be? And then various people could offer scientific explanations. But to just sort of close the door, in a way you could argue that Chip, or someone like Chip, who believes in an alternate interpretation, I'm sitting in the middle of the bridge, so it could be either way, he should feel strong, because I interpret that as a manifestation of fear and uncertainty. Because if I really had confidence in my paradigm, I'd put it right out there and say, well, yes, there is a bridge there, but this is it's either this explanation or it's that explanation, but certainly it's not what Shepard says. But instead to just say it isn't there, that's a manifestation of fear, I think.
This misrepresentation of the results on a public level, published through a press release from a government-supported institution, which was not refereed and which gave the wrong information, seemed to escalate, in my opinion and my colleagues' opinion, escalate the controversy into a publicity campaign, which was sort of like doing scientific research by press releases in an attempt to defend, as a sort of a last resort, a dying paradigm in physics.
I don't know what more one can do than the data are there, they've been got, we have to make sense of it.
I think in one sense they think it's bad to, quote, confuse, unquote, the public. Because if you believe in the standard paradigm with all your heart, you know it can't be real. I know it can't be real. You know, if I try to be at all rational within the context of the current Big Bang ideology.
Of course, this is astrophysics, this is science, and everything can be refuted. You have an explanation, you can produce an opposite explanation, so not everything is not so simple.
The theoreticians ought to be really looking at this theoretical problem, and the observers ought to be gathering much more data of the sort that we get. But I think they're all a little scared because it's an unpopular subject. They're worried about their jobs, and they're worried about getting moving on up the ladder. You know, if they're postdocs.
A young person in academia cannot afford to go against the Big Bang. He'd immediately lose his position, tenure.
Tenure, yeah.
As I said last night. And so there is this difficulty. You can't expect them to do that.
Don't collaborate with Chip Arp, or don't collaborate with Geoffrey, because if you do that, you will have problems to get a position in such a place. I received such a blackmail.
When I was a student, I was naive. And when I saw the chance to work with Chip Arp, he sent me a letter. This is 30 years ago, in fact. Good heavens, I hate to even think that it's 30 years ago. And warning me now that you may find some people put off by an association with me. And I didn't even understand what he was talking about. I thought, I'm just trying, we're just looking for the truth, aren't we? We're just investigating other areas, alternatives. But I found, indeed, that it was not this way, and that there was a great deal of hostility.
To anybody with an open mind, that should really prove the case that quasars are associated with galaxies at most ordinary kind of redshifts, while the quasars have higher redshifts. Therefore, they must part of the redshift must be non-cosmological, not to do with the expansion of the universe.
Because I'm always thinking, if we can only be more rigorous, they will believe us. But I was wrong. I was very naive. It's got nothing to do with that.
The rolling of the Big Bang, it's largely been determined by the way people seized upon these ideas, and there's been tremendous amount of propaganda making claims that here we see everything happening and this has to be right.
The people that are in that field treat it like a religion.
And not very objective.
The reaction of the Orthodox astronomers to this idea is that it violates the Big Bang assumption, the Big Bang hypothesis, and therefore it cannot be true.
The amateurs tend to be more broad-minded than the people who have to earn their keep by being narrow-minded. I got it.
Was this worked out by somebody, or was it, did it just happen by chance? Which is really the same thing as saying, did the universe happen by chance? And I have to say, when I look at it, it doesn't look to me at all like chance.
the Thunderbolts project came out with something that was really pretty extraordinary this week. But I wanted to start it out with, something that NASA has said, of course, and, like, who was it that said it last week? It was Chris said it last week, that basically the electric universe theory is pretty much, banned off of Wikipedia. I don't know if that's true, but it wouldn't surprise me. I do know that they don't like to address it because, it's very clearly an electrical / magnetic construct, and they just don't want that getting out there, I think, because that is the secret to revealing our true cosmology. So here is something that NASA has been, quoted as saying, on the cosmological scale, there's no data to suggest that magnetic fields are present. They certainly are not important in the dynamics of the universe for any reasonable range of field strengths consistent with present observational constraints. Of course, this is by NASA, which is absolute rubbish, because every university that has a astronomy or astrophysics department realizes that there absolutely is magnetic lines. Not only are there magnetic flux lines, but they stretch in their model hundreds, if not thousands, of light years. Okay, so that's a bunch of nonsense. So what I want to do is, and this is just one quote that is on their newest, Thunderbolt's newest, that they got from a guy at University of Toronto. And this one was just released on the 14th by Thunderbolt's project. But anyway, they say, not only are entire galaxies magnetic, but the faint, delicate threads joining galaxies are magnetic too. Everywhere we look in the sky, we find magnetism. And of course, if we let this play a little bit, I'm just going to let it move up to the next quote, which is going to be coming right up here. I should probably just play it faster. All right, then they say, in general, we don't know how such magnetic fields are generated, nor how these large-scale magnetic fields affect galaxy formation and evolution, which, of course, I know how they are. I get it. And that, again, that's when you bring it back to, something a little bit more local. So then they say, understanding the role that magnetic fields play in the evolution of galaxies and their environment is a fundamental question in astronomy that remains to be answered. Of course, Jane Kaczmarek, University of Sydney. So what I want to do is I want to play the very first part of this video, and this will be under fair use because we are commenting on it, and hopefully Thunderbolts wouldn't mind anyway, but we are going to call fair use on this, and we're going to play like the first 4 minutes of this, and then I'm going to make a little bit of a comment on it. So let's go forward here.
Universe, brought to you by the Thunderbolts Project at thunderbolts.info. What fills the vast space in the unimaginable distances separating celestial objects in the cosmos? Space is indeed a big place, but it's not a perfect void or vacuum. Today, this fact is acknowledged even by the NASA Space Agency, which states in an official report from 2014. Space may appear empty, a soundless vacuum, but it's not an absolute void. It flows with electric activity that is not visible to our eyes. The movement of electrically charged particles requires a medium, and that medium in space is plasma, or the so-called fourth state of matter. Plasma is commonly referred to as a gas whose constituent atoms have been split into electrons and ions, which move independently of each other. Well over 99% of the visible universe is composed of plasma, including the Earth's ionosphere.
One thing I want to comment about that is, in order for there to be gas then in a supposed perfect vacuum, I'm not even sure where they come up with that, because it would be immediately drained off into the vacuum itself. It would be dispersed everywhere, and there would be no place for these electrical currents to be taking place. So my point here is that, even though NASA is saying that, yeah, now they're finally saying, in stark contrast to themselves, that there are these electrical currents, and of course, what do electrical currents produce but magnetic fields? But they're saying that the catalyst for this is plasma, and plasma requires a gas, which it requires it to be charged. Now, the problem with that, again, is you run into all kinds of problems with gas dispersion throughout free space and all this stuff. But like Iru was just talking about earlier, yes, in the upper atmosphere there are all kinds of gases, and the reason that they're there is because they are not allowed to escape, because there is some sort of a lid, if you will, over the flat Earth, whether it's a firmament, a dome, whatever, or electromagnetic in property or crystalline, whatever. It's because it is a closed system, and what NASA is calling this plasma is only even possible in a closed system, because again, when you think about the idea of a gas in a perfect vacuum, that's just nonsense. It doesn't make any sense at all, because it would disperse all over the place. So what they're actually seeing is they're seeing these electrical manifestations that are indeed propagating through plasma, but it's not thousands of light years away. This is a very, very local phenomenon. And again, if we weren't in a contained system, we would not be able to keep these gases there. They would be literally sucked off, or blown off, I should say, by any pressure out into the far reaches of space. So I just wanted to say that, but the bottom line is that the cosmology of the Earth is very definitely being looked at in a very different way, in that they are understanding that gravity just doesn't cut it. When they try to apply the Newtonian or Einsteinian model of gravity to deep space, it doesn't add up, and that's why they have to constantly make up things like dark matter and all kinds of weird things like black holes and stuff like that. Whereas again, if you simply bring this idea of the electric universe and you put a lid on our construct, where we can actually have these gases in the upper layers of the atmosphere without them being blown off into space, then all of a sudden this makes a whole lot more sense. Then you can have plasma, then you can have charges going through the plasma. This is what gives us the clear indication of electromagnetic lines of force that they are measuring in abundance. Every university in the world is measuring these, in stark contrast to NASA's BS statement that they're not there. So that's all I'm saying, is that yes, they're so close to being on the right track, but somebody really needs to ask the question at NASA, or not just NASA, because we know they're BS, and we also know NASA knows the answer to this, but people need to start asking the question, is how are the gases able to form in clouds or be together in clouds? And if they talk about certain gas clouds that are up there, and what exactly is keeping them together? Is it supposed to be gravity? And when the current passes through them, shouldn't that disperse the gravity or actually burn up the gas or do something with it? Why would it remain in a static form? That doesn't make any sense. So these are the kind of questions that I think eventually even the guys at Thunderbolts Project are going to start asking about this model. And what Eero has explained here about these specific gases, the oh crap, I forgot the gas he was talking about, but anyway, but that acts as a natural dielectric. These are exactly the kind of things that we need to create the electrical construct and plasma construct in our skies, that will give us then our luminaries, our stars, and a lot of the phenomenon, the lights in the sky that we see from the aurora borealis on out. So that's basically what I wanted to say about this, and I want to go back to Eero because he's still got a bunch of great stuff, and I will elaborate on this a little bit more next week. But as I've said many times before, the guys on the Thunderbolts Project are so close to being right on the money, but still there are so many things that are not explained as to how this gas propagates through space if there's no quote-unquote atmosphere up there. It's supposedly being distributed in what we are calling, or what they are calling, somewhat close to a perfect vacuum. So any comments on that before? Oh, go ahead.
Yeah,
Tom.
I was just going to say before we move on, I totally agree. It's spot on about gases in the so-called vacuum of space. I did a video not too long ago. It's flat Earth star and planet formations. is totally impossible. And it runs into the similar problems, but there's so many catch-22s with just basic fluid dynamics. I mean, fluid dynamics 101 stuff that anybody that knows anything about how gases operate and how a vacuum and gases operate, you can't have the atmosphere adjacent to a vacuum. You can't have nebulae in the vacuum of space that are creating stars and planets allegedly. You just can't have that sort of thing in a negative pressure environment. Gases, fluids, whatever, even plasma should technically expand to fill the void of that vacuum, that negative pressure environment, which is allegedly infinite in the globe Earth theory model. And so, you can't demonstrate anywhere in nature where fluids or gases or plasma behaves like this. So why is that a staple of the globe Earth theory? I mean, it is just ridiculous to me, just absolutely ridiculous.
Yeah. I totally agree. And somebody just made a comment in the chat, well, if there's enough gas out there, gravity will affect it. And of course, if that was true, then we would see these gases in spheres not being quite so nebulous, right? So the gravity, of course, they can't demonstrate that. There is no way that can be demonstrated, period.
Well, it's another one of the catch-22s, because the atmosphere or the atmosphere in quotes is more dense lower to the ground and less dense, allegedly at super high altitudes in the globe theory. And so gravity, not only would it be affecting those gases less and less with altitude because of the density, but also because of the proximity. Those are the two key ingredients to quote-unquote gravity, is density of the objects and the proximity of the two objects. And so as the gas gets less and less dense with altitude and the proximity increases with altitude, then you have sort of multiple exponential factors that are that would theoretically have gravity affecting the higher altitude gases less and less and less with altitude. So how does that cap off, right, at a vacuum? I mean, come on, just give me a break.
Yeah, it doesn't work. And another thing I also wanted to comment is, they're describing this, when you look at the sun and you look at the holes in the sun or the sun spots, they look through them and there's basically nothing there, and the temperature is thousands and thousands of degrees less, which would lend great credibility, in my mind anyway, to the sun being some sort of a projection. But I did notice a comment last week that somebody was saying that, those magnetic lines, that what we were calling magnetic lines of force around the solar eclipse was actually, what did he say? Something else. But what he did say was that the magnetic lines of force coming from the sun actually looked more spaghetti-like. And it's like, no, that isn't the magnetic lines of force, because the magnetic lines of force will remain in a toroidal construct. What appears to be spaghetti-like are these plasma filaments that are going up. That's the thing that looks spaghetti-like. So I did see that. I can't remember who the guy was. Fudmotten, I think, was the guy that said that. But that is absolutely wrong, and I just wanted to make a comment about that. So yes,
Good point.
Yeah, in order to have, gas floating around in space, then if it's attracted to each other, if there is a gravitational force that is actually doing that, then it would have to act like every other thing that they tell us it does in space, and that would be that it would have to form up into a ball. Well, that isn't how it works at all. We see these supposed plasma fields or gas fields, nebulas that are, going across, stretching across light years supposedly, and they have no uniform form to them. They do not appear to be contracting into any type of sphere or anything like that. So again, it's a whole lot of conjecture on the astrophysicist's part and of course NASA's part, and all of this is to ignore the idea that the universe is indeed electric, and that most of the phenomenon, if not all of the phenomenon we see in our skies, can absolutely be shown to be an electric effect.
My institute, saying that unless I changed my line of research, that they would have to take away my telescope time.
One of the frightening things, I think, for conventional astronomers is to accept the fact, or to realize, that these intrinsic redshifts for the quasars and peculiar galaxies and so on, active galaxies, means that a lot of the things which we thought were out at great distance in the universe are very much closer in.